Vector and energy calculus. Vector and vector and commercial calculus. Vector and energy calculus. Vector and commercial calculus. Okay, why I renamed energy as commercial? Because it looks lucrative, it looks monetary. Otherwise we are in discussion with vector and energy calculus. Vector and energy, they are tied to each other in a sense that energy has magnitude and energy has direction. If someone is running, then he must have a direction and he must have a magnitude. Why I use this? It looks like energy source. Okay, I mean, there is a way to see something. If someone is running, people would say a human is running. But to me, a energy source is running. If someone is running, means there is an energy source. Inside the energy source, energy is getting converted into kinetic energy and he is running. If he is energy source, then he has a direction and he has a magnitude. Magnitude and direction together makes a kind of energy. Now, if there is energy, then there is a force field. There is energy, then there is a force field. Human also has energy. Tree also has energy. Very few people know that tree, they are assembled in a certain fashion. If you see, go out and see a small tree, big tree, small tree, big tree. For a human being, it looks like all trees are independent, but that is not true. Okay, set of tree, they are kind of, they come in the force field, energetic field, energy field of bigger tree. Similarly, if you see the society, if you see the village society or society, then lot of people, they come under the head of the village. Head of the village is the main person, means his energy level is high. Under his energy field, all people live in the village. Not only in the village, in India there are 5 villages that they live under a energy field of one person. People know what is the name of the person. So this is energy field. Nowadays, if you say the prime minister post in any country or head of the state, in his energy field, full country lives. So energy has significance. If there is an energy source, then there is an energy field all around him. I believe it is called aura or something like that. Okay, if there is an energy field is also called force field, gravity field, acceleration field, whatever it is. If anything comes in the vicinity of the energy source, then that item will start moving toward the energy source. If it starts moving toward the energy source, then energy source is losing energy because it is making item move one point to another point. Makes sense? So if I am very high energy source and because of me one person is moving one location to other location, then I am losing energy. Typically, if he comes towards me, then I lose energy. If he goes away from me, then because of me, it's not that through his, then I gain energy. Okay, this is typical concept of energy. Anyway, energy source is of two types. One is called path dependent, one is called path independent. Path dependent, path independent means if because of me, I am one energy source, because of me, one item is moving from here to here. Okay, energy what I lose making the item move from a point A to point alpha, point A to point alpha, that energy is dependent, energy what I am losing, that is dependent only upon point A and alpha, distance between it, not on the path taken. If item takes straight path, item takes circular path, whatever it is, the energy, net energy that I am losing depend upon the my energy field, force field, and the begin point and end point only. If it is path dependent, then begin point, end point, and the path it takes. If it takes longer path, kind of elliptical path or circular path or straight path, depending on the path, it varies. Now, If my energy source is path dependent, then how much it is path dependent? Some energy source can be near to path independent. My energy source is path dependent, but very less. More or less, it is path independent only. My energy source is completely path dependent. Completely path dependent means if you change the distance between point A and alpha, the energy consumption will change. Path that much path dependent it is. How much path dependent it is? For that calculation, one calculation comes is if this is energy source or this is energy source, and if I move an item from here and bring it back here, I am not bringing. Because of energy source, item is starting from this point and coming back to this point again. If that is the case, then energy consumption you calculate and divide it by the area. Normalization of the energy consumption from the energy source when item is moving from one point and coming back to the same point. If it is path independent, energy calculation is zero because begin point and end point is same. If it is path dependent, energy consumption will be there as per the circular. But if circle is less, energy consumption will be less because distance cover is less. If circle is big, energy consumption is big. But I want to calculate the path dependence nature of the energy. How much is it path dependent? Divide it by the area. If energy consumption is more because the line is bigger, then area is bigger. This is called normalization in the energy consumption. It is called circulation density. So circulation density is something like whatever the energy consumption is a closed loop divided by the area. That talks about the nature of the energy source, how much is it path dependent. Other calculation is calculate the curling factor. I have demonstrated, I believe, many times. Curling factor, curling factor means okay, I have kind of energy source. Okay, so this is energy source. Consider this is energy source. And curling factor means this is the item that is going toward the energy source. If it is going toward the energy source and it is rotating, while going toward the energy source, it is rotating. If it is rotating while going toward the energy source, it is called curling. There is a curling in it. If it is going direct like this, then there is no curling. But if it is rotating while going toward the energy source, there is a curling. How much is the curling? That also talks about the path dependency. It is a completely different thing. Okay, path dependence means point A to point B. How much is energy calculation? How path dependence means how much it is dependent upon the path from point A to point B or point A to point alpha. Item is moving. How much it is energy is consumption from this energy source. If it is moving in circular, how much is the energy consumption? If it is moving in elliptical, how much energy can? If it is too much dependent upon the direction, distance or direction, then it is highly path dependent. Okay, one way is take from this point and come back to this point and divide by the area. Whatever the energy calculation is divided by the area. Whatever comes, that is called circulation density, or that is the how much it is path dependent. Or or calculate the torque factor, how much it is rotating an item when it is moving towards it. That is also about talks about the path dependence only. There are two factors. Curling factor. Now we are in phase of proving that Earth gravitational pull is path independent. Means an item is moving towards Earth, it will fall directly. It will not rotate. You can try. So it will fall directly. It will not rotate. If it is path dependent, then how I know it is path dependent? Very easy. Just make it fall like this, and if it rotates, then it is path dependent. Okay. One way of is calculate the curl factor. Calculate the curl factor. That we tried. What is the gravitational force of the Earth minus gm divide r vector divided by r to the power 3, more or less, not exactly, more or less. Minus gm is constant, more or less is r vector divided by r to the power 3 in polar coordinate system. If this is Earth, then any item is here, then this is the radial. This is polar coordinate system. And what angle you make, that is the theta. So polar coordinate system is radius and theta. Okay, what it makes. If it is here, angle is 0. Then it moves like this, then angle is 90 degree. Pi by 2. Pi. 3 pi by 2. 2 pi. Okay, if that is the case, then gravitational pull force is minus gm, that is constant, r vector. R vector. Minus means towards itself. Divide by r to the power 3. Okay, can we calculate? In past video, we have actually proved it that it is path independent because curl factor, that is df2 by dx. I mean, we calculated curl factor in 3 dimension is, you play to calculate the curl factor in 3 dimension, take 3 rows. One is I, j, k, first row. Next is d by dx, d by dy, d by dz. Third is f1, f2, f3. F1, f2, f3 are three component of force field. Here the three component of force field is r vector by r to the power 3. R vector is xi plus yj plus zk. Then r to the power 3 is x square plus y square plus z square to the power 3 by 2. Then the F1 first field vector is x by x square plus y square plus z square to the power 3 by 2. Next is y by, third is z by. Now we calculated. Someone has to calculate curl of this. So to calculate the curl I, j, k as first row, second is d by dx, d by dy, d by dz. This is also called gradient vector. Third is the F1, F2, F3. Settle it down. Whatever comes determinant, that is the curl vector. We calculated, it is 0. Can we calculate? A question is arising. Can I prove the path independence of the earth? I have never tried it. Path independence of the earth by calculating the circulation density. Circulation density through circulation density. Can I calculate the path independence of the earth? What is circulation density? Calculate the energy calculation in a closed loop divided by the area. Now, Earth gravitational pull is my xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 minus gm I am taking away. Okay, this is force field F1, F2, F3 dot d of position vector. Dot d of position vector. Now, we took example. Okay, now we took example. Consider that we have a earth. So consider that we have this earth, and around the earth item is moving in this circle. This is up. This is earth, and one satellite satellite is moving around the earth. Okay, one satellite is moving around the earth. If it is moving in a circular fashion, then how much is the work done when item is moving from here and coming back to here around the earth? What is earth? So what is energy calculation? That is force vector dot displacement vector. Force vector dot displacement vector. If force vector is in algebra and displacement vector is in algebra, then better to go with the integral calculus. So force vector dot d of position vector, integration from point A and back to point A. Make sense? So what is the position vector? Okay, force vector f vector dot d of position vector, because d of position vector is the displacement vector. What is displacement vector? What is displacement vector? Displacement vector, at any point displacement vector is along a tangent. Up. What is displacement of the circle? Okay, displacement is along the line. Along the line, if I draw a vector, that is displacement vector. Line, I know, line is circular, but vector will be straight only. Here, vector will be like this, 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 vector will be like this. Vector will keep changing. If vector keeps changing, it is an algebraic vector. That is only possible thing. Okay, at any point here, what is the equation of the algebraic vector? What is the equation of tangential line at any point x comma y? That is, at any point x comma y, you have to calculate dy by dx. And if I say at x comma y, or if I say x0 comma y0, x0 comma y0, what is the differentiation? Then you have x square plus y square equal to a square as the circle equation. Then x equal to square root of, sorry, y equal to square root of a square minus x square. dy by dx minus x by square root of a square minus x square. If I know dy by dx, okay, I don't want to go even below it. So if I know dy by dx, that talks about the slope. dy by dx at that, now if I have dy by dx is minus x by square root of a square minus x square. This is generic algebraic equation. Okay, very nice. Now tell me, what is your dy by dx when x equal to zero point 0.5? Then minus zero point 0.5 divided by a square, that is the radius of the circle. If it is 1, 1 minus 0.25, square root of 0.75, point minus 0.5 by square root of 0.75. So that is the dy by dx at any point 0.5. At different x, the dy by dx will be different, because at different, this is x axis, this is y axis. If I take different x here, y will be here. A different x dy by dx will be different. That is led by the formula minus x by square root of a square minus x square. Now I'm trying to find what is the vector at each point. Okay, how you deduce vector equation? This is my question. Okay, if I say, if I have a line, if I have a line equation that is y equal to x, y equal to x, line equation is generally y equal to mx. M is the slope. M is the slope. Y equal to mx, or y equal to dy by dx into x. If I talk about line at point x0, this is x-axis, there is a point called x0. This is y0. What is the equation of the tangential line at point x0, y0? Y equal to dy by dx at x0, y0 into x. If x0 is 0.5, then it will be y equal to minus 0.5 by a square root of 0.75 into x. That is the equation of the line at point 0.5. What is the vector? What is vector? If I ask anyone, can you tell me the vector equation? Okay, very nice. Can you tell me any point through which it is passing through? Yeah, I'm telling you. It is passing through point 1 comma 2. Point 1 comma 2. Okay, vector is point 1 comma 2. Okay, then one point is origin, I believe so. And another point is 1 comma 2. Means I plus 2j. 1 is x minus 0, 1, x, I, but 2 minus 0, 2, 2j. I plus 2j is your vector equation. Means if I have, then what is dy by dx this of this vector? What is your y? 2. What is x? 1. 2 by 1. This is our fundamental to find the vector equation of a line, where line equation equal to y equal to dy by dx into x. If you know line equation y equal to dy by dx into x, then how to find vector equation of this line? Vector of equation of any line is the x minus 0, that is position vector. Or if you take 2 points, x0, y0, and other point is x1, y1, what is vector? x1 minus x0i plus y1 minus y0j. If I know dy by dx, doesn't it talk about two things? One is dy by dx, for per unit change in x, how much unit of y is changing? Dy by dx equal to minus x by square root of a square minus x square. This is the kind of circular differentiation. Means it is passing through. I am trying to find where x is variable. I am trying to find a vector whose x is 1 and y is minus x by a square root of a square minus x square. This is not available anywhere. You can search. Please do support us. +91 is the India country code. 94831 60610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country code. So if kind of if I know dy by dx, then for 1 unit of change in x, how much y is changing? That is nothing like you are passing it up to a point that is 1 comma dy by dx. Makes sense? If that is the case, then the vector equation, if I know dy by dx, then vector equation of the line is I plus dy by dx j. I plus dy by dx j. If that is the case, then vector equation of tangential line, because I know dy, if I say y equal to dy by dx x, dy by dx talks about the slope at any point on the curve. Y equal to dy by dx into x is the line equation of the slope. Okay, vector equation I plus dy by dx j is the vector equation of that line. This is what we are looking for. Because position vector, the kind of, if Earth is like this, then Earth gravitational pull is minus gm I am leaving. Xi plus yj plus zk r vector divided by r to the power 3. Okay, force vector dot d of position vector, d of position vector or displacement vector. D of position vector is displacement vector. All everything will see. Okay, whatever the vector now. So this is force vector of the earth, that is radial. If earth is at the center, then force vector is radial at every point towards the earth. And displacement vector is tangential. Now I have to do dot product of this, or force vector dot of position vector, force vector dot d of position vector, or force vector dot displacement vector. If displacement vector comes in algebra, then all right. Okay, so displacement vector is I plus minus xy square root of a square minus x square j. Now do dot product of these two vectors. Okay, xi plus yj plus zk divided by whatever it is. Now zk just leave it because we are talking in two dimension right now. xi plus yj, xi plus yj, denominator I am leaving right now. xi plus yj dot with x, my xi plus yj is the earth gravitational pull dot displacement vector, that is I minus x by square root of a square minus x square j. Square root of a square minus x square is y, that is a circle. This is I minus x by yj. Now do dot product of these two to get the energy calculation. Xi plus yj dot I dot xi plus yj dot I minus x by yj. If you do dot, it becomes x minus x, 0, 0. So energy calculation, if there is earth as a center, and if I make anything rotate in a circle from this point and coming back to this point like a closed loop, then first of all the force dot displacement vector is 0, no energy. Means earth is path independent. Earth gravitational pull is minus gm r vector divided by gm r vector divided by r to the power 3. If this is the gravitational pull, then energy calculation in the circular fashion, one point coming back to that point itself is 0. Someone can try in other way. I'm not saying that hard and fast rule that use the energy calculation as per the circular direction only. Anyone can take elliptical direction, or anyone can take a straight line. Consider this is earth centered at the origin, and draw a line like this. That line equation is y equal to x. Line equation is y equal to x. Okay, we'll complete the position vector fundamental. So energy calculation is force vector dot d of position vector. Position vector, if I talk for a circle, then any point here x, position vector will be xi plus yj. Now earth gravitational force is xi plus yj dot d of x plus yj. Okay, now we'll come to the same situation. D of x plus yj is dx plus dy. Net energy calculation is x dx plus y dy. Y is square root of a square minus x square. Dy is dy by dx into dx. That will come at minus x by square root of a square minus x square. Dope, dope. Finally, it will come at x dx minus x dx minus x dx, 0. Okay. Now someone can try the path independence of Earth gravitational pull. If Earth is at center and there is a line from center, and the line equation is y equal to x. Mean dy by dx is fixed one. If that is the case, then line equation I plus dy by dx j, I plus j. I plus j is the equation of line that is y equal to x. Now one item is moving from point 1 comma 1 to point 2 comma 2. See how much is the energy calculation. Add it when item is coming back from 2 comma 2 to 1 comma 1 and see it is 0 or not. Now start again. That is xi plus yj plus zk. Xi plus yj plus z. I am talking only in xy plane. If that is the case, then z is gone. Xi plus yj. D of position vector. Position vector. D of position vector. Okay. D of position vector. What is position vector? If I take position vector here, that position vector and the whatever it is, d of position vector or dot displacement vector, if I know in algebra. I know in algebra displacement vector is I plus j, or the position vector is xi plus yj. This this is center. Earth is kept at the center, and there is a line from Earth that is in direction vector, that is I plus j. Okay. Anyway, if I take any point here that is x comma y, then position vector is xi plus yj. Let's proceed. The position vector is always xi plus yj only. Now we have Earth gravitational pull is xi plus yj plus zk. Consider I am doing in xy plane, z is 0. Then xi plus yj divided by x square plus y square to the power 3 by 2. Okay, dot product with d of position vector xi plus yj dx dy. Now it will become x dx plus y dy divided by x square plus y square to the power 3 by 2. Now let's start. If what is y? X dx plus y dy whole divided by whatever it is. Now we are trying along a line that is y equal to x. Y equal to x. We are trying along a line that is y equal to x. Then it will become x dx plus y dy. That is again it will become x dx. X dx plus x dx divided by x square plus x square to the power 3 by 2. Hold it. So it will become 2x divided by x square plus x square to the power 3 by 2. That much the energy computation from point A to point B. What about reverse direction? Then your vector will become reverse. The right hand side, it will become minus now. I'm sorry, everything will become minus. What is the vector equation of this? This is I plus j. What is vector equation in opposite direction? Just place minus there. Minus and in braces I plus j. This is the vector. This is I vector. What is this vector? Minus I. This is j vector. What is this? Minus j. If this is I vector, then this is minus I plus j or minus I minus j vector. If we do the computation, everything will become in minus. So this component and this component will become 0. Again, this is again not available anywhere else. Energy computation of Earth in a closed loop. Closed loop also becomes in a straight line also. Item is moving from one point to other point, and from that point coming back to same point in a straight line also. It also makes a loop kind of situation, where one side the energy computation is something and other side it is exactly opposite. And since it is coming in linear form, that is 2x dx by 2x squared to the power 3 by 2. Okay, then it will come as exactly as negative. If I calculate this, positive and negative exact amount will lead to 0. So Earth is indeed a path independent. Okay, you're sorting this much here and there. Tell me why one path dependent formula. Now everything you will prove it is path dependent only, independent only. Okay. Now try. There is another equation called minus yi plus xj. Minus yi plus xj. Consider this as an assignment. Now consider Earth gravitational pull is minus yi plus xj divided by x square plus y square to the power 3 by 2. Now prove this is path dependent. The formula we gave through circle and a straight line, use same fundamental and see it is zero or not. If it is not zero, then Earth is path dependent. If its gravitational pull is minus yi plus xj divided by x square plus y square to the power 3 by 2, then we will see curl free vector also. Amazing, mind blowing. Okay, so please do support us. +91 is the India country code. 9483160610 is a telephone number. 9483160610 is the telephone number. +91 is the India country code.